Here we go, CodeZone episode 31. Wow. I'm just repositioning the camera. It looks like I'm a little bit sort of filling the frame today. Maybe I've gained weight. I don't know. Anyway, yes, welcome. CodeZone 31, and it is a Wednesday, not a Tuesday. My apologies for that. As usual, my life is sort of being tipped upside down at the moment, and it's been complicated by the OLC Code Jam 2021. A very important thing because we're still open for people to take part. As usual, fill in this space because there'll be ads playing for certain individuals of different territories. And what are we going to talk about in this episode? Well, it's going to be state machines because I had a bit of a brainwave about state machines and how I want to approach doing them. And we've got some people. So we've got Magetsub, hello. Danicron, hello. Dragoneye, hello. Holy Mackerel, I think that says mackerel. Alter Ego, hello. 13 Digits, howdy. Saucy63, good evening. Myri, hello. Yes, I haven't seen Myri for a while. Starfreak Clone, excellent. Starfreak Clone is here. Ooh. That's quite important, actually, because I need somebody that actually knows a thing or two about C++, and we might get to some discussion about that later on. If you don't know, Starfleet Clone wrote an article recently, and it's actually a very interesting article about modern C++ features, particularly modules, and definitely worth a read. There's definitely some links kicking around on the Discord server, but feel free, one of the mods, if you can post one of those links for now. Who else have we got? Charnel Mouse, hello, yes. And we've got Starfleet Clone. Oh, Starfleet Clone, we already said. Megarev, Mohammed, hello. Yes. Very good. Right, and now I was looking at the Space Thing code, and it's becoming a bit unwieldy. And we discussed a few episodes ago that it basically needs a lot of refactoring. And one of the things that I felt needed refactoring, even though in an earlier episode of the Code Zone I was kind of thinking about state machines and how I like them and how I don't like them and what I want to do with them, it did occur to me that, well, a lot of the code is basically state machines. So if we go and have a look at the on-user update function, we're doing the drawing, but the first thing we'll do is go straight into a state machine to handle the user interface. Well, the problem I've got, Starfreak, is I'm going to show something tonight which I've been sort of hacking together, and it's horrific. It's going to make people cry. It's so terrible. And then I tried to implement it using sort of modern C++ paradigms, and it was even worse. In fact, it was so bad I couldn't get it to work, and I believe that that's just my ignorance of the language and syntax. So we'll get to that as we discuss. I'm sure there are some experts, particularly on the C++ channel on the Discord server, that should be able to help me out trying to understand it. But in the end, I resorted to an old school technology, which does work, and we'll see some demonstrations of that. But the reason is I've got lots of state machines, and there's a lot of code happening in the state machine. So here is a state machine for user interfaces. Idle states, and when we want to change state, we basically specify the next state down here, and the loop goes away and does it. We have a state machine for the user interface. We have a state machine for... Now we'll go back down. So this is the state. The user interface one is sort of the main game state machine. If we go down here, we've then got another state machine, which is for handling the camera. Ooh, lots of pings going on. Let me just turn that down a touch. This is for handling the camera. Which is quite a nice idea. I like the idea of the cameras being somewhat automated. Hello. There's something. Got a lot of people going on. What's going on? Have I missed something? I don't know. Gondar, hello. Magetsub, new font. No, I don't think so. Don't think so. Maybe not zoomed in as much. And Alex is here. Alex is going to sort everything out for us today. With all of the new features C++ has, not everybody knows. Speedy! Hello, Speedy. Oh, very good. Oh, good. I'm glad Speedy's here. So, yes, we have another state machine for handling cameras. And then we had another state machine for handling rendering. And, that's all. Rendering one's a little bit more simplistic. It's not really a state machine. It's really a state machine output for the user interface state machine up above. And it occurred to me that I've been programming in C++ now since... realistically, probably about 1998, something like that. And you go through a phase where you're formally trained things and you're not formally trained things, and back then, that age, I didn't care about design patterns so much, but I sort of discovered that there isn't really a state machine pattern in C++. It's just, well, in dev. I mean, obviously a state machine exists, and we'll have a talk about what a state machine really is, but there isn't sort of a sensible pattern for it. And I was curious about that, so I then started to try and implement something, and we'll have a look. Oh, we've got the code police here. I'm never going to pronounce. If it's just a consonant and a vowel every other letter, I've got no hope of pronouncing that. But hello anyway. Yes, Alex is going to sort out all of our modern C++ problems that we're going to have. And tonight, I should point out, I'm hardcore tonight. I am drinking the most hardcore beer in the world. It is Tesco no added sugar bitter shandy. Oh yes, that is, that's hard stuff. Right, guaranteed to put hairs on my chest. That's what it's for. Ah, good. So we've got some people here. So yes, lots of state machines, and I was curious: is there a pattern to sort of stop me having to implement this every single time? So state machines are always implemented in switch case blocks. Is that a good thing to do? So let's have a think about what is a state machine, because not everybody's that familiar with a state machine. If I just pull up this, there we go. Yep, dazzled you all, and I've already lost my pen. There we go. Now, what colour pen have we got? So state machines. We have covered state machines in a few of the YouTube videos, but they're a nice tech to sort of simplify a complex sequence of events. But I wanted to look at state machines sort of in a more pure point of view, and there'll be all of the real-time and control systems freaks that are watching this they'll probably shout at me for using the wrong terminology. I always get mixed up between my Morley and my Mealy machines and all that sort of thing. So it's a useful tool, a state machine, and the idea is that at any one time your state machine exists in a state. And I'll represent states with this square here. And depending on things that happen, the state machine can change state. So let's say we've got a state machine here with 4 states like this. Making sure I'm not drawing into the text box. Well, that's it. So a very good state machine pattern is to use function pointers. And we're going to look at that because I got into some trouble with some function pointers. So that's one of the things I want to sort of make sure we've got some C++ experts in the chat to help me out with, because it ended up, I liked it, but it could probably be done a lot tidier and a lot better than the way I did it. So the point is that at any one time we can exist in a state, and a state will output stuff depending on what the state is. So it's got some output. And we'll just label our states A, B, C, and D. Now, we can choose to either output the stuff here, or we can say something along the lines that when we're in A, let's say state here, am I just below the camera? Good. So when it's A, then we output whatever we need to be. And when it's B, we output something else. So this is sort of the traditional digital state machine. Oh, see, on the videos I can edit all that. So this is the traditional sort of state machine. We don't actually output directly from the code that represents the state. Instead, the states really represent a series of transitions and gates and sequences. So whilst we're in state A, we can effectively stay in state A, which all the states have this implicit loop. It sort of goes back into itself. Or we can respond to something happening, which takes us to a different state. So, for example, to leave state A here, we've got some sort of event or some sort of data or some condition, something happens, which we determine, well, actually now we need to go to state B. And we've got a different set of conditions that takes us from state A to state C. And these have these little implied sort of little loops here that actually, once you're in a state, you always stay in that state until something interesting happens. So, I don't know, maybe this could be player presses jump, for example. Not relevant to space thing, but it's something has happened. Or in this one, player hits question mark block. I don't know. Something happens. And once we've been in this state, perhaps this state then goes over to D, which is, I don't know, something like check for landing. It could be any kind of thing. Whilst we're in that state, we're constantly checking for landing. Has that happened? And if landing is true, let's put 1, then that can be our condition for going to state A. So really, it's just a way of describing a complex hierarchy of if statements. But in sort of a structured way. And there's lots of like mathematics and notation and language and things to describe state machines. And within states, you can have sub-state machines, and you can have state machines that sort of operate a little bit differently. So here we're always depending on the lines represent the events and the conditions that happen. There is another type where you can have the states themselves represent the conditions and the lines sort of represent the states. A bit more of a different architecture to think about state machines. I will get my professional state machine coder out. Morgos. I like that name. I make super crude state machines. Yeah, I think that's what we all do, because in C++ you can do that, and that's exactly what we've been doing in Space Thing. We'll go back and have a look at some of the code for Space Thing. What we tend to do, or what I tend to do, is everything in the same place. So let's go and have a look at the first state for the user interface, which is our idle state. Nothing's happening. We specify states for our camera state machine, so we've got some inter-state machine interactions going on there. But here we have something happening, some logic is going on, and depending on the nature of that logic, we determine another state to set. And we don't just immediately set the state, we always go to set a next state variable. So that way the rest of this loop for this frame can finish, and it can finish in a predictable way. But next time round, what do? We probably do it at the end of the state machine. We set our states to our next states to make sure that's true. Or maybe I do it, oh yes, there we go. State now equals state next. So the next iteration round, we're in a different state. So everything can happen in a predictable way. Very useful way of sort of organizing your sequences. 228 hooligans, hello. Hooligan, sorry. Blue Booger, 4 states of the state machine. Polymorphism with the state machine classes and put them in standard stack. And standard int is here. Hey standard int, hope you're alright. So I thought, well, this is how we all typically do state machines. Is there just sort of a clever way? And as RHK has already spoilt, yeah, I think there probably is. But what I wanted to try and avoid, and I've mentioned this in a previous video, is that you can sort of object orientate this to death. And that's sort of not the approach I want to go with this project. Nothing against object-oriented programming, obviously, that should be quite clear. But it's not necessary sometimes to go to the nth degree to define lots of objects for everything that we want. So I proposed a different structure, and I had a little play with it. And I just want to make sure I get the right window here. So this is, yeah, here. And I'll talk you through my sort of hacked together implementation. So I was hacking this yesterday evening, having a think about what's going on. And in principle, what I want is an object which is a derivative of a state machine. But because I'm interested in games programming, I'm interested in doing things sort of every frame, I kind of need my state machine to sort of be part of that ecosystem. It needs to understand that frames are a thing, and that there's going to be constant update, and how the output works, and that sort of stuff. I'm just going to have a quick swig of my hardcore beer. Hang on. Volian, hello. Yeah, I'm not too bad. Thank you. I'm pretty tired actually. X10's been keeping me awake. Hence, I'm on the hardcore beer. Oh, and I should point out, those of you on the Discord server, you probably know the moderator Hoolig. You see him kicking around. Hoolig showed me something, and I immediately bought one. And this stream was actually going to be doing this instead, but I thought I'll save this for a different time. He showed me a 3D puzzle, and I shall bring it up here. And it's a hurdy-gurdy, which is an instrument, which is basically like a string-based bagpipe. But it's also a puzzle, so you have to sort of build it yourself. I don't think there's any instructions in this. and we can actually play it when we finish. And I thought that would make an interesting sort of Saturday afternoon stream or something like that at some point. So we'll have some. It's all good on the CodeZone, is it? Just random, sort of all over the place. Who knows what we're going to be talking about next? Ethiel. Hurdy-gurdies are the best. Well, they're not sort of a common thing in the UK. Pandemonium, first time catching a stream. Well, welcome. Yeah, don't usually do them on Wednesdays. Typically do them on Tuesdays instead. It has a crank. It does have a crank, yes. And you can say all for my name. Okay. Right, so yes, I want a state machine that sort of operates like this. And I kind of like this idea. So I'll show you how it works. So here is my state machine. And it is a class, and this is where people will start to groan and go, oh dear me, what evil is Java getting up to here? So my state machine derives from a base class called state machine. Ignore this little bit for the time being. And I figured that lots of different objects could work like state machines. So I kind of, in my space thing game, I want my spacecraft to have like an AI state machine. And that can vary depending on what the craft wants to do. I probably want an AI to handle things like the camera, and an AI to handle things like maybe some of the non-player stuff that's going to be in the game. I've kind of got a bit of a vision where I want the game to go now as well. I've been thinking about it, and so I want lots of little state machines all over the place. That's why I'm creating this sort of tidy way of doing it. So a state machine should always have a reset function, so you can go to a known state. And I wanted something that was sort of syntactically quite pleasing to use. So I didn't want to have to go and create a load of custom enums and have my own switch case statements and things. Just remembering the basic rules that my states are sort of exclusive, and they do really sort of one thing and one thing only. So in reset we have this function called setState, and that will set the state machine, which this class could be sort of anything deriving from this state machine base class. State machines are hard. Yeah, they're unusual because you kind of feel. What in the hell? Sorry, I'm reading on. What the hell is that circular inheritance? Good. I'm glad we're angering some people here. Megref, different. We're talking sort of a slightly different type of state machine. You're thinking of sort of game state kind of state machines. So that's you'll load up your menu, and then you'll go into a menu, and it'll bring in a different part of the game, sort of moving around space, and then perhaps you go into a sub-menu there, and you can sort of stack up the current game mode. That is indeed a state machine of sorts, but it's not sort of a traditional state machine. And I also have issues, I think we've discussed in the previous episode, with people that represent game states on a stack, because most of the time the stuff that you've pushed onto your stack, you don't care once you've gone deep enough into the game. You don't care whether your title screen still exists. You might want those resources being loaded. So there's I don't know, not for me. But I know it is a popular technique to do it. The only time I tried to use a finite state machine, I got myself into a complete mess because I kept changing my mind. Yeah, see, that's it, Chalmers. It's about the discipline, and that's what I don't know how well this will work. So that's why I've created a separate project to sort of, well, pardon my French, but dick around with this concept and idea. Nullbiter, hello. Finally able to watch a live stream. Yes, very good. Oh, it's good to have you here. So we've got a reset condition, and you can see that this is an override. So you must have a reset condition. But my states are just functions, and that's what I quite like about it. So I don't have a big switch case statement. I just have this functions called state, and because it's in my game engine, there are a few peculiar requirements. I want that all of my states, when they're updated, get the elapsed time constant. That could be quite useful, but they also get a Boolean flag, and this flag here is to tell me, has the state just been entered, or is it in continuous sort of operation? So the first time we enter state A, this is true. Subsequent updates where we're still in state A, this is false. I think that's a very important thing, because often in a state machine you want things to happen just once. But because this is sort of a game engine state machine, perhaps the state is travel to planet. Well, there's obviously lots of activity that needs to occur whilst that state is being updated. So that it's active, it's alive, that state machine. Now, that kind of breaks the rules of a state machine, potentially. Ideally, what you'd have is some sort of observer looking at your state machine saying, well, you are in state A, that means travel to planet, and the observer then goes away and implements that logic. And that might be something that we still go down on this approach. We'll have a look. Entry equals initialization. Potentially, yes, because it's up to you whether you choose to use it or not. So all I'm doing in this case is just writing out to the console that we've entered this state. Now, my state machine object here has some properties. It has some counter here, which is just going to be incremented. And if it's incremented, this is our condition for changing state. Now, at the moment, I've not thought about a way for external state changes. Now, that's an important thing that we do need to have a think about. I wanted to try and come up with some way of gathering environmental information, in which point the state could make an intelligent decision about where it's going to go to next. But for now, in my simple experimentation, and this is really an experimentation in the architecture, not necessarily the function here, then we can choose to go into a next state. So if we don't call the next state function, it is assumed we stay in the same state that we're in. That's golden rule of a state machine. But it's quite nice because these are functions of the class. They are well, they're not sort of enums. So syntactically, I quite like that. That's a nice way to think about it, and it means I can name my functions whatever I want. I can keep them quite useful. They need to be used in this context of a state machine, but that's okay. I think the people writing the code will understand that actually this is dedicated state machine stuff, and my approach to this is going to be to have a sort of informal rule that it must begin with state. I don't think there's a method in C++ where I can enforce that, can I? Don't know. Have you ever considered introduce state transactions? Well, possibly, yes. We're right at the beginning of this. Thank you, Nanoic. Yes, good for you. I guess being a pod person isn't doing everything for you. What have we got? When did Javid start using /n over standard endl? That's a good point. I tend to choose one or the other, and I know the differences. You don't need to lecture me about them, and honestly, I don't care about the differences. But I think in this case, it was just code brevity. This really just is sort of hacking it as I go along. Can seat. Hello. Can't require function names, but only signatures. Why don't you make separate classes for state? Well, that sort of goes to what I was saying earlier. It's very possible to completely go object-oriented nuts on this, but I wouldn't do that because the state machine itself is the object. The individual states are really just an integer. They're an index. They're a finite point within some state space. They're not necessarily objects themselves. So it's debatable, right? There's lots of interesting ways to implement this same sort of thing. Now, cross-platform support, it is always optional. From what I heard, we're still talking about /n. Yeah, everybody knows about /n and standard endl. That's like one of these proper code bore things to talk about, isn't it? It's anyway, we actually scienced that out on the Discord and found that using standard endl in most cases is it's negligible, the actual delay. Davey40k, hello. Trying really hard not to see enum there. Well, yeah, exactly. We could go down the enum route, and I might still even go down the enum route because I was actually thinking it would be useful to have the state machine have some sort of automatic debugging properties as well, in which point I need to have reflection in the code. Now, C++ doesn't support reflection like a lot of languages, but you could do that. I was thinking I could have sort of a map which actually defines the state transitions, and I was thinking also of coupling a lambda function into actually those transitions as well. So this is the start of I guess a bit of a journey for me conceptually to go down. But we'll carry on talking about the state machine. I'm just distracted by some of the chats here. Each state could be a class with override virtual functions which extend a base class. Stored in an array of variable state pointers with defined enum for state indices. This is a real example from Ubisoft game code. Yeah, it could be. Could be. But I'm not doing it that way. No reflection yet, at least. Well, I don't know. I don't think C++ isn't really about reflection. I think if you're relying on code being able to understand itself like that in a non-debug capacity, I should point out debug capacity reflection is very useful. So anyway, I've defined some states. If it goes into state A and it gets to larger than 5, the counter, it goes into state B. And when we're in state B, it does nothing else other than reset the counter and goes back to state A. State C is never called. So I'm going to try and run this and just make sure that it actually works. That's an encouraging start. And if I click the... Actually, no, I'm not going to click play because that's going to be a disaster. Instead, what I'm going to do is run the debugger in release mode. It's all good, isn't it? Where is my console window? Where's that gone? Console window? Hello? Console window. There we go. Ooh, this could get a bit tricky because it's on a different window, isn't it? Okay, I'm just going to F10 that a few times. Since we're on stream, just let it do a number of updates, and we'll analyse what's on the output here. So here we've got our entry A, so that was displayed the first time we went into the state, and then we've got 1, 2, 3, 4, 5. I think we've got one more of those. Let's have a look. Yeah. Oh no, we go straight into B because it's on this. Yes, that was the first entry. So that was our first one. We looked for the condition of greater than 5, so there'll be 6 A's. Then it goes into state B. And then it's got confused because I'm trying to debug this in release mode, which is probably not ideal. Let's stay that back into debug mode. There we go. Try that again. Also doesn't help that I'm having to ping this window around. There we go. I can't make that stay on the top. I'll just run that a few times. We can see here in the debug output, some counter is now moving around. And we can actually interrogate the state S. This is the variable here, S, which is an object of my state machine. And my state machine has this private member, some counter. We can see that changing around. But the base class that it inherited from is doing all of the state machine stuff. And I guess we'll have a look at that in a minute. So here we've got entry B, simply reset the counter, and then went back into state A. And that repeats itself. So we've created sort of a sequence of things which is now sort of independent of how many times there's been an update. This is good stuff. This is kind of state machine stuff. I tell you what, Starfreak, I'm going to make you a Twitch mod because that will then sort of there we go. That will allow you to start posting things. I think since I trust you to posting, so you may need to try posting that link again. Rather than using enums, I use structured types, which can possibly hold their own data. It leads to a lot of nice properties. So that's an interesting way too. Oh, the chat is in front of the debug window. Well, the chat is more interesting than the debug window. So, functionally, the state machine works. Now, let's have a look at the sausage meat, because everybody likes sausages, but nobody likes to know how they're made. And I think that's where we're going to start seeing. This is probably not a very nice way to do it. So, it was correctly pointed out at the start that what is going on here. That my state machine is inheriting from a base class state machine, but that state machine is being templated with this current state machine. So we've got this sort of kind of like circular inclusion of state machines going on. You have to make videos more often. Canseat, yes, thank you for the support there. I do make, traditionally I did make videos every 2 weeks until about 3 months ago when my offspring was born. And I'm just having a little bit of a break from doing videos whilst I've got a newborn kicking around the house. So that's why there's not been anything for a while. Although we'll have a few with the jam, and I'm doing these streams. I think these streams are a good in between at the moment. Ah, good. So Starfreak managed to get the link posted there, and you have the ability to ban people now, Starfreak. So be careful, be careful. Don't annoy Starfreak clone. Yeah, a hash map is sort of an interesting way, and I think that's ultimately the way I'm going to go with this. Perhaps in the next episode, I don't know. I think with a state machine, you've got to make the decision. Do you need super performance? Arguably, you always need super performance, but maybe you don't. Certainly, a lot of the state machines in my Space Thing game, I don't anticipating updating every frame. There's probably going to be batches of them updated every 20 frames or something like that. So I don't think having super performance switching between the states is actually that problematic. But if you did represent your states by registering an enum with, or a string name, or an enum with a function pointer or something like that, you could create a fairly reasonable mapping between the two. Anyway, let's have a look with this state machine here and state machines with my state machines as a template. So let's go and have a look at this class. So this is something you don't often see on my channel. It's a template class where I'm passing in the sort of token FSM, which is going to be the whatever my derived class is going to be called. And yes, as somebody mentioned, we're going to be using function pointers. It was RHK77 mentioned we're using function pointers, and here is my type def for all of the things that define a state in my system. So this is the double that represents the elapsed time, and this boolean represents that entry flag. And this is just for convenience and to make sure everything's in the same format all the time. Oh, well, thank you, Kansi. I appreciate that. How would FSM work in threads? I can't imagine how it'd look in structure. Well, it doesn't really make any difference, unless it's difficult if you could have your individual threads inside states, then things might get a bit complicated. Function pointers, delegates. I'm in C# land. That's a good question. I can't answer that, I'm afraid, because I don't know. I presume there is an equivalent function pointer in C#. You could also break up the work between inputs and send it to different threads. Yeah. It depends. It depends on how you define the input. And that's why I think there isn't sort of a defined way of doing state machines. Because there's always sort of unique requirements. But I was trying to come up with a basic model that could satisfy a lot of my sort of simplistic state machine needs. So my base class here, that's a template class, has a single virtual function which makes it abstract. So there can never be an instantiation of the state machine directly. It always needs to be sort of customized with an actual state machine implementation. And it turns out this is actually quite important for making this all work, because if this isn't virtual, if we actually provided reset here, it gets really confused about what it should be calling at any given time. So by making this abstract, it kind of tells the compiler, or it kicks the compiler into touch and says, well, hang on, you can't directly have this state machine, therefore any of these assumptions you've made about ambiguous pointers and things, they can't apply. So it kind of helped me along looking at that. We might explore that in a minute. So I have a function in my state machine called update, and this is the one we pass in the elapsed time. And all it simply does is there's a flag that says do a reset. Now, the first thing, why am I checking this in update? That's because reset is effectively asynchronous. Anything can choose to reset the state machine, including states themselves. So I felt it was quite important that because I can't reset in the constructor either. The reason I can't reset in the constructor is because I can't call the virtual methods of a class in the constructor of the class whilst it's being constructed. So you needed a flag there to sort of work around that. And then we've got this, and this is sort of the line. Right? This is the line of code. That one. I'll just let that one settle in for a minute whilst I find my beer. Well, arguably, Megarev, OpenGL is just a state machine. It's actually how it works. Yes, Nanoic, I'll show you the alcohol that we've got here today. It's hardcore. Tesco, no added sugar, bitter shandy. I'm not sponsored. Oh, it's good to see. There's a lot of debate about state machines going on. I mean, hands up. How many of you have had like formal training in state machine design? That's not beer. It says. Hang on. Right. It says ingredients: carbonated water. Second ingredient: beer, barley, 10%, citric acid, acidity regulator, sodium citrate, barley extract, preservative, flavorings, sweetness, stabilizer. And at the bottom, what does it say here? It says contains no more than 0.5% alcohol by volume. Yeah, it's got an alcohol content. It's a beer, Nanoek. It's a beer. You see, I did a lot of my state machine training at university. It's not one of those things you sort of pick up if you're just hacking things yourself. If you actually go and do a genuine course on control systems or real-time systems engineering, something like that, state machines are a big deal because there's all sorts of maths you can do with state machines. You can do like state machine calculus and that crazy, horrible, complicated things. You had substantial formal training in state machines. Doesn't mean it was good training. That's sadly very true. I don't find my I remember my state machine lectures, and I don't particularly feel like the lecturer was engaged with the course material. I'm actually more impressed right now. Why isn't there sort of this tremendous train of vomit appearing in the Twitch chat at this line of code? I mean, is everybody just sort of looking at it going, yeah, you know what, that's all right? I'm very surprised. Is it possible you can't see the line of code? This is horrible. Right? This is absolutely horrific. In all, I mean, look at this. What's going on there? Learn state machines about Turing machines. By the way, first time here in a long time. Glad to see you still doing interesting stuff. Oh, thank you, Prince Kiwi. Appreciate that. Hang on, my phone's going ping, ping, ping. Something's going on. I have to double check what's happening here. Okay, it's all good. It's all good. It's all good. Did you go to school in the 1800s? Well, automata means different thing to different people. Yeah, I thought that too, Stavik. The dynamic cast could be unnecessary. Let's see what happens. I think it'll be fine. The reason I chose dynamic cast is when I was writing this, I was really being guided by the warnings and the errors being given by the compiler, because I was struggling to sort of fathom this bit out myself. And it said you should use here dynamic cast or static cast, and it just said dynamic cast first, so that's what I went with. But it was interesting that it gave you the choice of two. So what's happening here? Well, basically, this, don't forget, is actually the object of state machine, but it's a template object customized by my state machine. So this is actually sort of my state machine. The trouble is, the compiler doesn't understand that very well. So I need to actually cast that to the templated form of my state machine, because that's where my functions exist. And because I'm calling function pointers which are member functions of the class, you have this sort of unusual syntax here. This is actually legit C++ syntax. It's horrific, but it is a legit thing. And that allows me to call the current state function pointer, which is defined down here, current state, which, remember, my type def tells me what that function should be. And that's calling my elapsed time variable. So it's calling with the elapsed time variable, and this is setting the Boolean flag value. So I maintain the previous state as well, so I can tell that if my previous state wasn't the same as my current state, then I need to set that true, and that will only be true upon entry of the state. So a complete mouthful, a horrible mess going on there. It could do with being split across a few lines. Well, I kind of went with dynamic cast anyway, because I've always assumed, well, in my head, dynamic cast is when you sort of want to change sort of the relationship of the OOP hierarchy. So I'm sort of, with dynamic cast, I'm deliberately telling it, well, this is sort of a subclass that's going down. The reason static cast works here, I think, is because it's not really a subclass. That's why it's confusing, because this class doesn't actually really ever exist. It's all very, very confusing, and this is why I love C++. It's good fun. I'm enjoying this one. Let's catch up with some of the chats. There's been a few here now. It checks to see a type to be casted is an inherited type of the pointer. Yeah. Function pointer syntax is always weird. It is. I forget the syntax when using pointer to a member. Well, that's it. So it's this little nasty thing here. But it's got to understand what this is, and that's the bit that took some time, because I was just blindly throwing this at this and hoping that the compiler would kind of understand. Well, this object is actually the same as the object that we've created down here. This should return the same value for both of these objects. But the compiler can't. It wasn't smart enough to sort of understand that that's what the intention was. It's just fine. It's quite a complicated construction. When in doubt, just use auto. Oh dear. So that's the line that does all the magic. All that happens then is we update the current state, which is the same as we saw in the space thing before. Once you've set a next state, we update the current state. But I'm also caching the previous state. Now these should be completely, well, almost free, right? These are just basically setting a value to another value, unlike if we were using standard function. And that's how I started this journey. I began with standard function, and that became a complete minefield. I was very surprised. All my next state function does is set the next state function pointer value. Just throw in ampersands and asterisks until it compiles. There's some truth to that. It's all smoke and mirrors. It is all smoke and mirrors. But it actually works quite well. I don't see this as being a particularly non-performant way of implementing this pattern. But what I need to work on now is actually how do we use this in reality, because I think there's still some complexity that needs to be understood. I don't yet know how my states are going to choose their conditions. Obviously, something's going to have to sort of donate information to this state machine. And I kind of like the idea of having the conditions for states to sort of be externalized, actually expressed as potentially lambda functions sort of plugged into the state machine. Don't know yet. Is this the latest version of your state machine implementation? It's today's version of my state machine implementation. I was just curious about whether it's sort of an interesting pattern to use or not. Is it any easier than using a switch case block and doing it all in one lump? So if we go back to the space thing code, I just found with the space thing code, you could call functions in this. I think the cost of indirection is probably, is it the same as a table lookup? This is probably a few cycles a bit quicker, I think. I guess if we get this thrown into a compiler analyzing tool, we would start to see some results. But I don't think at the moment using actual genuine old school function pointers there's actually a problem. The problem became using standard function, because standard function was inadvertently creating copies and bits and pieces like that, and I don't think I fully understand the purpose of standard function. The documentation is not clear when it comes to using it, and it also seems to require the use of standard bind as well, which was making this sort of syntax unpleasant to work with. It became very, very wordy to make it happen, and that, I think, as no secret on this channel, is a bit of a gripe I have with C++ these days. Is it's become too verbose for its own good. That twang there is the ring pull getting caught on the official One Lone Coder mustache. You kind of like the pattern. I kind of like it too. I like the fact that it's self-contained. So now I don't need to actually define the states anywhere. Just by the sheer state functions existing, they are defined. And I quite like that over and above having a separate set of enums somewhere that you've got to maintain. If I don't want a state to exist, I just remove it from the code, and the compiler will shout at me as well if that's the case. See, so if I've not got the state, the compiler will go, yeah, well, that doesn't exist, so that's not allowed. Which that sort of thing does make coding life just a little bit easier. I can't tell for sure, but it looks like a lot of the complexity in the current code is from the FSM updating a lot of things outside itself. Yeah, and I think that's a really good point, Channel. I did sort of touch on it earlier, that state machines, when you do them in C and C++ or any programming language, it is tempting to sort of add loads more functionality there because you can. But if you're trying to sort of stick to genuine state machines, then I think there's restrictions on realistically how much you can shove into a state machine. So my intention is to have sort of a state machine which is inherited for, say, my spaceships. So let's say, for example, this was not my state machine. Instead, it was transport ship AI. And we'll just replace those. So transport ship AI. Everywhere that needs. I know there's a shortcut to do quickly all the changes, but I like refactoring manually. The reason I like refactoring manually is because it forces you to actually examine each one individually and just double check that it's what you need to do. Interestingly, that's one of the reasons I'm pro Hungarian notation. Some people really don't like it because it makes refactoring difficult. Well, if you're at a point where you need to refactor your doubles into unsigned chars, then you probably need to just start again. But I quite like the fact that changing a variable in one place, it does make you think about where you're changing it later on. So I would have a basic transport ship AI, and then potentially I would inherit from that what it is to be a transport ship. Now, that might not work because I guess the stuff in the state machine needs to sort of look at what are the properties of the transport ship. So things are perhaps working in the wrong direction there. It could potentially be that my transport ship AI is just a member of the transport ship. These are, things that I still need to figure out yet. Not fully fleshed out the ideas. So I think that will be the next step, is to look at how do we handle the input gathering side of the state machine pattern. Where does one buy an official mustache? Please show the main state machine again. Do you mean the one in space thing itself? Well, there's lots going on in this state machine. And I guess the test for this technology is to try and re-implement this and see where we need to make things changes. So let's look at a different state. So object is selected. So when you've actually selected on a planet or a moon or a satellite or something like that, we set up what the camera is doing. These are some ECS specific things, but they're quite important for knowing what's the next state to go to. So this is if we've selected a planet, we can place an orbital marker. If we've selected a moon, we can place an orbital marker. If we selected a space station, then we go into space station edit mode as the next state. So this works, right? And I don't necessarily have any complaints with this technique. If I look and compile this, my state machine. Oh, I don't know how that's managed to get there, but we'll take that out. Must have been some error copy and pasting. There we go. And let's just remove the GUI we've been working on. It's getting a bit annoying that now, the GUI. Let's move that. It was skinned to show that it could be skinned a different colour. So the whole point is everything in the game is actually managed by a state machine. You can see the state up here is idle. And this is the reflection part that I was talking about earlier. It might be possible to sort of make that happen as part of the state machine construction. If we moved away from sort of the function pointers being the index, So this is not selected appliance in idle state, and now we've got object is selected state. And if I press the what was it? Is the S key? Is it? Yeah. Place orbital marker state. Click on that. Object is selected. It's the new satellite. And if I go into there, we're into space station edit mode. So all of this is just one big state machine handling all of this complicated detail. I can go back into a state as well by pressing escape. So, and that's quite a nice way to handle those transitions. No, I don't think the state machine is the wrong approach there. I just feel that the code for the state machine is making it slightly unmaintainable because it's all these big monolithic lumps with what's going on. A co-worker had a great quote about sound. Why using standard function is like using semi-truck when what you really wanted was a bike. Yeah, it's a strange thing, standard function. It seems to be very heavyweight too. The Visual Studio rename button is incredible. It's useful. Nothing wrong with Hungarian apps. Hungarian. Yeah, I agree. Hungarian notation is good in dynamically typed languages. Someone asks about moustache. You've just shaved off your moustache, Alex. You had a proper manly moustache as well. The code that calls state A. Okay, let's pull that back up. So the code that actually calls state A is this line here. I will just so it's easier for people to see, I will put that across 2 lines. There we go. It can be analysed. Herbal Dance, hello. Chocolates, chocolate and milk, hello. That's a new person, chocolate and milk. I don't think I've seen chocolate and milk as a name here before. No, maybe I have. I don't know. I don't think so. Right. So this is how far I've got with my state machine. I think the next phase is to look at how we sort of gather input data, and I think there's a bit of thinking to do about that. And I potentially might even move away from literally representing the current state as a function pointer and maybe using some sort of map. I think it might be worth the performance penalty for the potential explosion in customizability. What I'm trying to get to here is I don't want to have to sort of manually create state machines every time I want a state machine. All of this stuff I want to sort of abstract away, but abstract away in a sensible way. I like the idea of just having a subclass with the states, and that's it. The magic is all happening behind the scenes. Now, I will say this is the last CodeZone before the OLC Code Jam 2021. And that Code Jam starts on Friday. If you've not registered, I do encourage you to go over to itch.io and register. The Jam theme will be revealed on Friday evening at 8 PM UK time. So the same time that this starts. That's semi-live. And as soon as I announce the theme, that's when the Jam actually begins. After that, there's 9 days, I think it is. Yes, 9 days to try and come up with something that represents the theme. And then it goes for community judgment, and that's an important part, the community judgment, because it is entirely community judged. You guys have to do the judging as well. So if you are submitting, make sure you download a few entries. Now, usually on the Discord server, if you know, we've got streaming capabilities on the Discord server too, and it's quite common for several members to go through all of the submissions and start streaming them. And you might think, oh well, jams, jams don't get that many submissions. The One Learn Coder ones do. We do very well. The last few jams, we've had over 100 submissions per jam. So it does take a bit of time to go through them all and work them all out. Now, one of the reasons and one of the motivations for doing Pixel Game Engine using Inscripton was for jam entries, because if you do make your application browser-based, it's more accessible for people to try. Nobody likes downloading an executable and then fiddling about with the security settings to make it work. It just makes people feel uncomfortable unless you've got a virtual machine to sort of handle it all. And then you start thinking, well, I've got to power up my virtual machine, it's not going to run properly, I'm going to have hardware issues, all that sort of stuff that goes with it. So, as much as I begrudge having things running in the browser as being the best way forward, for jams it kind of is, and it's always been the case that the stuff that runs in the browser tends to score a bit more highly. However, we'll see this year if we can adjust the scoring system to take that into account. because a lot of the interesting stuff is the stuff that doesn't run in the browsers. Why not use the linked list of functions? Okay, that's actually not a bad idea. Well, it wouldn't be a linked list because that would just be a sort of serial approach, right? It would be always one state going into the next state, going into the next state. You'd have some more complicated linked list, perhaps a custom node structure, where each node could potentially go to 5 or 6 other nodes in that structure. That's possible. And that might be what we look at when we look at using a map type structure in the background instead. Oh, thank you, Dragonite. Yes, link to the Discord there and the Code Jam stuff. Yeah, it's good stuff. Is it exciting to be a father? It's. I tell you what, people sort of can get all blubbery about this sort of thing. It's genuinely life changing. The amount of responsibility that you feel for this bundle that just pukes on you and poos on you and wheezes on you and sneezes on you and spits on you and then cries all the time and then just demands to be fed, and you think this by all accounts shouldn't be something that I care about, but at the same time it's a pleasure to have all of those things done to you. Complex big chunks in the finite state machine. I've seen versions where all the chunks are small, but it could pass through several states. Check for him. I kind of lost the thread of that one. Sorry, Child Mouse. We don't like serial here. For serial queues. Yeah, you might want a graph-like data structure there. Yeah, and that's potentially where you should be going with these state machines. I guess it depends at some point. You just want to hack these things and make them easy to use. There's no point using these technologies and making your dev life more difficult if it's easier to just stick with a big case statement because that's what you're familiar with and it does the job. There's nothing wrong with that at all. Don't assume for a second that I'm sort of suggesting that approach is a poor approach. It isn't. It is tried and tested and works very well. I was curious that it doesn't seem to be a pattern that you see very often, and it's probably because there's magic code happening, and that's where things I think probably fall down with this approach. You see a class here with some functions, state A, state B, but what you don't realise is you can't call these functions directly. There is some background magic going on that needs to call these in a particular order. So I guess from a puritanical dev perspective, these are a bad idea. It's a real bundle of joy. I'm really selling it. You prefer a simple linked list with a quick return if the state is not active? Oh, well, I mean, these will return if the state isn't. Oh, that's the thing. Like, I think that statement there sort of indicates a way of thinking about state machines. A quick return if the state is not active. Well, the idea here is it'll only call the active state. The other states don't exist. And I guess that's why it's interesting from a theory point of view. There's no testing of the states to see, well, are you active? If not, we'll move on. It's just the state is the thing, and that's why I like it. That's why I like this approach. A weird one to describe. Well, we're almost out of time. So I would like to know, are we going to have a thumbs up for, potentially, not next week because it's Jam Week, but the week after, the hurdy-gurdy construction stream? I think that's going to be a load of fun. I've got to do that. Hurdy-gurdy construction stream. Because I like musical instruments, and I don't know what a hurdy-gurdy is until Hulig showed me that. It looks like a lot of fun. I think it'll be good fun to do that one on camera too. We're also due potentially some other live specials because the channel is reaching a bit of a milestone number in subscribers, and I think it's probably fitting to do a bit of a live event. I never do it bob on, but we'll do something probably in the next few weeks. Because I'm aware that the YouTube channel is sort of getting a bit, cobwebs starting to form on it and things, because I've not been posting very many videos. You'd like to see the build? It might be one of those nice slow videos to throw onto the second channel. Right, well, thank you for all of those that have followed tonight. A bit of a crazy one, looking at state machines, lots of things to talk about. I'm really pleased that there's a good discussion. I hope that spills over into the Discord server and we can carry on arguing about the merits of all of these different approaches. Lesson learnt, fingers got burnt using standard function. I really don't understand why that's a useful thing to have. Herbal Dance, what, you bought a hurdy-gurdy of all instruments? Yeah, why not, right? It's got a great name. So with that, don't forget to join the jam if you haven't already, and I'll see you all on Friday for the theme reveal for the jam, and it's kind of going to be live. So thank you very much, guys. Take care of yourselves. Bye-bye.